Electricity powers almost everything around us, but behind the scenes, things don't always run as smoothly. In many homes, offices, and even entire neighborhoods, electrical faults are becoming increasingly common. But why? Well, let me share some of the reasons.
Let's have it. Let's have it.
1. Poor installation practices. Many buildings still rely on electrical installations done by untrained or inexperienced technicians. Wrong cable sizing, loose connections, and poorly terminated wires always create a silent recipe for disaster. 2. Aging infrastructure. Some buildings are decades old. The wiring inside those walls, even older. Insulation becomes brittle, cables degrade, and protective devices malfunction, thus increasing the likelihood of faults. 3. Overloading of circuits. We keep plugging in more devices, our fridges, heaters, TVs, and chargers. But the truth is, many of these circuits were not designed to handle such loads. The result, overheating and frequent tripping. 4. Power quality issues. Voltages in many places fluctuate, especially in places with unstable power grids like Cameroon. These sudden spikes in voltages causes internal component failure and damages appliances. Number 5. Moisture, dust, and environmental conditions. Electrical circuits hate moisture and dust. They lead to corrosion and short circuits, especially in outdoor and industrial environments. Number 6. Faulty or substandard electrical products like cheap cables, fake breakers, and low quality sockets. They often look fine on the outside, but are often very weak and unreliable. Please avoid them for your own safety. But here's the good news. Electrical faults can be controlled, and the key is using the right protective devices. And number 1, we have miniature circuit breakers. A miniature circuit breaker, also known as an MCB, protects the circuit against overcurrent, which means overloads and short circuits. When too much current flows through the circuit, the MCB trips instantly, preventing the wires from overheating or catching a fire. Number 2, we have the module case circuit breaker, also known as an MCCB. Think of it as an elder brother to the MCB. It handles much higher currents and provides adjustable trip settings. It's mostly used in commercial and industrial settings where currents are higher. And number 3, we have the residual current circuit breaker, also known as an RCCB. An RCCB protects people and not appliances. An RCCB protects against electric shock and earth leakage currents. Thus, it trips where electricity is flowing where it shouldn't, like at the back of your fridge. And number 4, we have the residual current circuit breaker with overcurrent protection, also known as an RCBO. An RCBO is basically a combination of an MCB and an RCCB. It provides protection against shock, overload, and short circuits all in a single unit. And number 5, we have the surge protection device. Now, the surge protection device, also known as an SPD, protects against voltage spikes, grid switching, and unstable power supplies. It's very useful where there are a lot of sensitive electronic equipment. And number 6, we have fuses. Simple but effective. They simply melt when current gets too high. Still used in some appliances and small circuits today. And number 7, we have the overvoltage protection relay. Its function is simple. It simply monitors the voltage and disconnects the supply when the voltage exceeds safe limits. Electrical faults may be very common, but they are not unstoppable. With the right protective devices, good quality materials, and proper installation, we can prevent fires, equipment damage, and even save lives. So the next time you flip a switch or plug in something, remember, behind that simple action is a whole system working to keep you safe. Stay safe, stay protected, stay powered. Did you learn something today? If yes, let me know in the comments. I've been Jig Jason, and I'll see you on the next one.